everyone. Welcome to this module that is the basics of classes, objects, and methods. We want to talk about object-oriented programming that we discussed it in chapter 1. Recall that an object is named by a variable of a class type. Objects have data, but they also can take actions. These actions are defined by methods. You've already been using some objects and invoking their methods. For example, you have created and used objects of type string. In this video series, we will show you how to define your own simple classes and how to use objects and methods of those classes. After watching this video series, you should be able to describe the concepts of a class, create objects of a class, define a Java class and its methods, describe how parameters work in a method definition, use the modifiers public and private, define accessor methods and mutator methods, write and use private methods within a class, describe information hiding and encapsulation, write preconditions and postconditions for a method, and also you should be able to draw simple UML diagrams. Here we want to learn about class and methods. A Java program consists of objects of various class types that they are interacting with one another. Objects in a program can represent either objects in the real world, like automobiles, houses, students, employee records, or abstractions like colors, shapes, and words. A class itself is kind of object. It's like a plan or a blueprint for constructing specific object. For example, we can have a class that is called automobile. As you see here, we have the class name automobile, and it has some data like amount of fuel, speed, license plate. And then we have some actions that we call the method, like accelerate or decelerate. So accelerate and decelerate are the methods or actions that we want to use for class automobile. Alright, we have a class of automobile, and these figures shows 3 automobile objects that are instances of the class automobile. So we can create or instantiate several objects of the same class. As you see, the first one has a name. Object name is Pat's car, and amount of fuel is 10 gallons, speed is 55 miles per hour, and license plate is 135XJK. And we have the second instantiations that is called Sue's car. Amounts of fuel is 14 gallons, speed is 0 miles per hour, and license plate is Sue's car. And in the third instantiation, as you see, the object name is Ron's car, amount of fuel is 2 gallons, speed is 75 miles per hour, and license plate is 351WLF. So as you see, we can have different objects of the same class. Okay, Here is a UML class diagram. UML is short of Universal Modeling Language, that programmers often use a simpler graphical notation to summarize some of the main properties of a class. So that is called a UML class diagram or a class diagram. In this example, as you see, this UML has 3 parts. The first part is the name of the class that we want to make some objects like automobile. And the second part, you see there are some variables that we need in our class, like fuel, that has a data type double, speed has a data type of double, and license that has a data type of string. So we can have different kind of data types, and this minus back of each variable name means that they are private to this class. In the third part, you see the methods, that we have 2 methods. The first one is accelerate and the second one is decelerate. So this plus sign means that they are public, so we can use them in different classes. So accelerate and decelerate, they have parentheses in front of them. That is the parameters that we're going to give them. Each one of them has 1 parameter. So here, double pedal pressure. Pedal pressure is an argument, a parameter as double for method accelerate. And in front of these methods, as you see, colon and void. This means that these methods are going to return back nothing. So void means nothing. They are not supposed to return anything. So this is kind of a UML class diagram that it's better before anything we design our class. We just imagine what we want from that class and put a name for this, that we can create some objects from that, and what properties it has and what actions it's gonna do for us.
Alright, let's talk about some of the basic characteristics of class diagrams. To help explain these characteristics, I'm going to make up an example to help illustrate. So let's say we're building a system for a zoo. And, by the way, these examples I'm going to use probably would never find their way into an actual program, but it'll make all these concepts easier to understand. So in our zoo, we'd want to describe the different things that are in the system. You represent those things through classes, and a class is depicted with this shape here. So what's in a zoo? Well, there are a ton of animals, so we could create a class for our animals. To do that, you just write the name of the class in this top section. If our class is animal, an instance of that class would be a specific animal. So the question is, how would you go about identifying each instance of that class? You do that through attributes. An attribute is a significant piece of data containing values that describe each instance of that class. They're also known as fields, variables, or properties, and they go in the middle section here. So for our animal class, we could create attributes like name, ID, and age. That way we could identify a specific instance of the animal class, like Ruth, ID number 304, age 114. These need to be formatted a certain way though. You start with visibility, which we'll talk about later, the name of the attribute beginning with a lowercase letter, then you follow it with a colon and the data type. For the name, we'd want to return a string, and we can format the other attributes the same way, except that we'd want to return an integer since these are numbers. Now that we've got some attributes for our animal class, we get to the bottom section here. This is where you put methods, which are also known as operations or functions. Methods allow you to specify any behavioral features of a class. So we might ask ourselves, what are some different behaviors of this animal class? Maybe we'd want to be able to change our animals' names. Like Ruth should actually be called Rita. So let's create a function called setName. We can also create a method for eating, since all of our animals eat. Methods also need to be formatted a certain way. You start with visibility, which we'll talk about next, then the method beginning with a lowercase letter.
Next, you put parentheses to signify the function you're going to program later. You can also add variables and the data type in here, but in most cases, it's not really necessary. We'll add visibility in parentheses to the eat method as well.
Now let's talk about the visibility. The visibility of an attribute or a method sets the accessibility for that attribute or method. So right now we have a minus sign for all of these, which indicates that each of these attributes and methods are private. They can't be accessed by any other class or subclass. The exact opposite is the plus sign, which means an attribute or method is public and can be accessed by any other class. Another visibility type is indicated by the hash, which means an attribute or method is protected. These can only be accessed by the same class or its subclasses. And finally, there's the tilde, or the squiggly as I like to call it. This sets the visibility to package or default, which means it can be used by any other class as long as it's in the same package. But that one is rarely ever used. In most cases, your attributes are going to be private or protected, and methods are often public. Let's quickly review these basics with another example. Let's make a class for employee. We could give an employee the attributes of name, employee ID, phone number, and department. We'll want all of these attributes to be private, and then we could create a simple method like updating the phone number, which we'll go ahead and set to public.
Let's look at classes in Java. Java is strictly object-oriented programming language. And as you saw earlier in all our programs, even for a hello world, we used class. So we write all our programs in a class. A Java class definition might look like this. For example, here we have public class student. That is public because we can create some objects from this class, that is student, and then we open some braces, curly braces, to write our program. So here we have public class student. That student follows by public class. We use public because we want to create some objects from this student, and we want to have access to this class outside of this class. And also we have the keyword class, and the student name, as you see, it starts with capital S. And then we have these curly braces that it opens and closes. This part is called the body of the class. So whatever is inside these curly braces is called class body. After defining our class student, so far you've learned that we usually have instance variables. That here, as you see, this class student has 3 instance variables that they are defining the attributes of the class students. So this class student has 3 attributes: first name, last name, and email. That when we create an instance of this object, we can just put some different first name, last name, and email. As you see, their data type is string, and also they're followed by a keyword like public that we talk about this later. It's better to be private. After declaring our variables, we have methods that the syntax is like here. As you see, we have 2 methods: public void add course, parentheses, course a course, and then after closing the parentheses, here you see we have a curly braces open and close that we can put our valid instructions and comments here. Whatever you've learned so far, like loops, while, for, decision-making statements, expressions, or whatever that is valid, like scanner, print out, print ln, to write your action. But here, as you see, the name of the method, before having the name of the method, we have public. That means this method can be used outside of the class student. But if we put private, we restrict this method only to this class student. And after public, before the name of the method, we have a keyword void that could be any data type that this method wants to return. Here, void means that this method is supposed to return nothing. And in front of add course, we have parentheses. Inside of this parentheses, we have course, a course, that a course has a data type of object course. That means this method has one parameter to input. So whenever we use this method, we need to give it a parameter, an argument to work with this one. And then we have public void print schedule. That means, again, this is public, means we can use this method outside of this class. And then void means that it doesn't return anything. And the name of the method, print schedule, in the parentheses we have nothing. That means this method has no input. And then in the curly braces, again, we can put our instructions, loops, decision makings, scanner, and print. And also we can define and we can have our methods outside of this class after the curly parentheses. Just to review, we had a class that has a class name, the body, and we declare our instance variables. And after declaring our instance variables, we can define methods. So it's not just one or two methods, we can define more methods. That we use this template, this structure in our projects and in our programs later in this class.